In this episode of Cube FM, I got a chance to speak to Miguel Luna, who's a principal product manager at Elastic. Miguel and I spoke about observability in Kubernetes, which helps you gain insights into the system state as well as formulating new questions based on the observed data. Observability in Kubernetes can be divided into different sections related to the observation of the application and, in addition, observation of the infrastructure. Metrics, logs, and traces are fundamental to observability in Kubernetes, as it is crucial for understanding a system's performance and health. Metrics and traces provide valuable information about the system. Each has its own focus and context. Furthermore, alerts and visualizations are important tools in observability as they allow identifying issues and understanding the system's health. In this episode of Cube FM, I got a chance to speak to Miguel about these topics, his experience with them, the role that we're seeing of different projects such as KateGPT and also OpenTelemetry in the ecosystem to have a further understanding of where observability is now and where it will be in the future with the integration of AI technologies. This episode is sponsored by LearnK8s. How do you choose the best instance type for your Kubernetes cluster? Should you use few and very large instances or small and many? When using an 8 GB 2V CPU instance, are all the memory and CPU available to pods? Is running the same Kubernetes node in AWS cheaper or more expensive than Azure and GCP? The Kubernetes Instance Calculator answers those questions and a lot more. The calculator is a free tool that lets you estimate costs for your workloads based on requests and instance sizes, explore instance overcommitment and efficiency, identify over and underspending by model error rates on your actual memory and CPU usage, compare instances between different cloud providers. It's an easy way to explore costs and efficiency before writing any line of code. You can find the link to the calculator in the comments. Okay, Miguel, welcome to Cube FM. First and foremost, what 3 emerging Kubernetes tools are you keeping an eye on?
So there are 3 emerging tools that I find particularly exciting right now. First up is KateGPT, which leverages AI to provide intelligent insights and troubleshooting suggestions for Kubernetes clusters. Next is K9s. It's a fantastic CLI tool that transforms the Kubernetes management experience. It creates a terminal UI. So this allows for efficient navigation and real-time monitoring of your cluster. And lastly, OpenTelemetry. So OpenTelemetry, I feel, is a game changer for observability. It provides a vendor-agnostic unified framework for collecting metrics, logs, and traces. One particular thing that I like about OpenTelemetry is its data model. So enables creating a context layer that provides out-of-the-box correlation for all signals.
I'm sure one of our previous guests, Adriana, who's very active in the OpenTelemetry space, will be very happy to hear that. One question, just because, we saw each other, previously in KubeCon and AI was being spoken about a lot. Since you mentioned KateGPT in the beginning, in your day-to-day, work, the things that you're doing, do you find yourself using AI a lot? Do you expect to be using it a lot more in the next 6 months? Where are you at with this whole AI trend?
So it's interesting because at some point, like the pattern that mainly like we start to approach, that like most people have been approaching, is just throw things at GenAI and wait what it comes back with. I feel that one thing that we've been exploring a lot is what if we can get GenAI not just to answer questions but also formulate the questions based on the data that it observes. So this iterative process will allow the AI to continually refine its understanding and predictions of the data. So for example, let's say if the system detects an anomaly, it could automatically generate a series of related questions, answer them, determine the best course of action, and even like suggest visualization. So this dynamic approach could not just think about like GenAI be, like Clippy on the side, like eagerly waiting for us to ask a question, more like GenAI is under the hood, supporting us with its knowledge.
Love it. And any reference I can get to Clippy is much appreciated. So as a 90s kid who grew up in the 90s, I really appreciate that. All right. So we did touch a little bit on, what you're doing in your day to day, but let's take a step back. what do you do? Who do you work for? What's Miguel all about?
All right. So I'm a principal product manager at Elastic. We're the leading search analytics company. So I specialize in cloud native observability. Originally from Colombia. I've been in London for 18 years. I came here and, the weather, the food, just, nothing that you can leave on the table. I love London. So I've been here working and I love tech. So yeah, this is mostly what a good summary for me.
And how did you get into cloud native in the first place?
So I was working in the telco industry and we had this huge monolith that restricted us to do only 4 nightly releases. So imagine like 26 releases per year. This was a huge blocker for any fast iteration on any lean techniques. And what we did is with engineering, we got this very brave proposal and we took it to leadership where we say, hey, let's freeze all feature building, like pause all feature building, and let's focus on getting continuous delivery out of the door. So we set up a proper CI/CD with test, delivery, the whole package. And during these projects, I was first exposed to Kubernetes. And, by the time I left that company, we're doing like 3,000 releases per year, which is crazy. Like any change could immediately. So basically think like GitOps implemented. Later, I joined Pivotal, which was shifting its focus from Cloud Foundry to Kubernetes. And as a product manager, I took one of my first challenges was like, I need to understand this Kubernetes thing back then deeply. So I began by writing article. I put myself a challenge where I need to write an article. I need to give a talk. And this journey led me to write an article that explained Kubernetes as a cookie shop. I think if you Google my name and like cookies and Kubernetes, you'll probably find it. And even I ended up speaking in KubeCon 5 years ago. So this marked my official dive into the cloud native world.
Now, it's no secret that the cloud native and, Kubernetes worlds move very, very quickly. How do you stay up to date with all the changes that are going on? What are your go-to resources?
So I like to stay updated through a mix of newsletters, podcasts like this one, community events. I find newsletters and podcasts very useful for the expertise that they bring, and especially on topics that are at the moment being relevant. But additionally, when I attend events like KubeCon, I make it a point to visit the smaller booths because it's fascinating to see that the innovative work being done by startups in the space is sometimes like mind-blowing, and it often provides a glimpse of what is going to come on the future.
And if you could go back and give yourself one piece of career advice, to your previous self when you got started out, what would that be?
Yeah, I wish I could. No, honestly, like I think it would be about embracing continuous learning. So the tech landscape changes rapidly. So it's all about staying curious and adaptable. So this is key. It doesn't mean that if you switch off for 6 months, then when you come back, you lost you lost the story. Is more about always having like eagerness to seek out new knowledge and skills, even if they seem to be outside of your immediate job scope.
Good. Now, as part of our monthly content discovery, we found this article, The Basics of Observing Kubernetes, a Birdwatcher's Perspective, based on your experience with a real instance. So we're going to take a look at this a little bit more in detail. Now, most listeners might link the idea of observability with Prometheus and Grafana. Of course, observability is much larger than that. But how do you explain it to those who still don't know?
Oh, great way to begin the meaty part. This question can take all the time. Okay, I'll give you a short answer. So it's crucial to understand that observability is not the same as monitoring. Monitoring is about collecting predefined sets of metrics and logs to track the health of a system. It's often about setting up alerts for known issues and thresholds. So monitoring is essential, but it deals with known unknowns. So the problems that we anticipate. Observability, on the other hand, is about gaining insights into the system's behavior, including unknown unknowns, So we need to get a more holistic view, allowing us to ask new questions, get answers about the system state, performance ad hoc, and even get a point where we understand answers to questions that we didn't even know that we needed to ask. So you mentioned Prometheus. Prometheus only gives you metrics which tell you something is wrong. But to understand why, you need logs, and to even understand where, you need traces. So the closer that we have got to forming this picture of the whole observability, comprehensive observability view, is collecting these signals that I just referred to, which are commonly referred as the 3 pillars. But we need to tie them together. If on their own, they give you a part of the story, but they're not good enough. And we even have now a 4th signal coming up, which is profiling. Actually, Elastic, company that I work at, like, we recently donated the Universal Profiling Agent to OpenTelemetry, and we are working on making this signal vendor agnostic and making it a part of the of this comprehensive observability view that we need to have.
So we take that definition, then if we move it into the Kubernetes context, how do how does somebody go about observing a Kubernetes cluster? Where do they begin? Is it with apps, nodes, physical machines, control planes? I imagine there are a lot of different things that have to be taken into consideration when we're thinking about monitoring, or as you said, much further, observability.
Indeed. Yeah, there are many layers to Kubernetes. So what I like to do on Kubernetes is approaching it in 2 ways. First, I love system syncing. So that's the perspective that I like to take, system syncing perspective, which is similar to, the Verge observability article that you mentioned, where everything works together harmoniously. So we call, in system syncing, this is called a holistic view. So we focus on the function of the system. So you simplify, you think, why do you have Kubernetes? So the answer typically is to run containerized applications in a reliable fashion. But how do you define reliable? So let's consider an example for applications running. So for instance, someone presses a button on their phone to play a song on Spotify. There needs to be a server ready on the other side to handle that streaming, and Kubernetes might be behind it. Now let's say that a group of users starts streaming at the same time, and you want to make sure that you service those users in the way that they expected. So that's to ensure that they are getting what they're paying for. So which is the ability to stream songs. So we start monitoring service level objectives. So when you start getting errors or issues, then you start seeing things like you are running over your error budget. So things start spiking. So you don't want to let it get to the point where things go wrong. You want to know that you are going in that direction. So it's important to understand and start with monitoring SLOs. Further below, you need to understand what is impacting the SLOs. So it could be that everything is pointing to a specific service producing these errors. Then if you keep going down, this service is going to be dependent on some pods from a particular deployment, which are locating then on a specific node. And I'll give you, let's think that this node is getting all the files from the song, is getting them from a specific hard drive. And that hard drive happens to be performing a backup at the same time where you're getting the errors. So we come to the realization that now you have, whilst everything was on its own, like working okay, because the database wasn't having any errors, but your users were, and the node wasn't having any errors. When we have this holistic approach, we realize that you have competing traffic that is impacting the why. We want to have the reliability. So as a result, we can schedule the backups in times where fewer users are streaming, and then we get more reliability as which is why we wanted to have. So you see that I began with the higher why, and when digging and found the root cause. The second aspect of my approach is I like to also define the boundaries of the system based on roles. So this is where I like to split Kubernetes in what I like to call the application and infrastructure layers. I'm pretty sure plenty of folks have their own names or similar definitions. So I have an image that I can share. Let me see if this.
Okay.
The application layer is mostly cluster users. So they are going to be deploying their applications in Kubernetes. So they're interested in things like services, pods, workload resources, which are the objects that Kubernetes used to get the pods deployed. So you want to be observing your deployments, your daemon set, your replica set. And if something goes wrong, these cluster users might want to have a sneak peek or at least some high level view of where these pods are running, but they probably don't want to start like ingesting all data about the nodes or control plane. So this could be a good boundary for me to set. Then on the other side, if we keep going down, we find the infrastructure layers where it's mostly where you have the nodes and the control plane and all its components. So if you're a cluster admin, then you think, okay, there is a problem. So I got one of my cluster users complaining to me and a specific node because they already some key indicators that are telling that. So let me investigate. Let me understand. I also might want to have some information about what's happening on the application layer itself. So for example, a cluster user A complains to me, and I can see that the node is struggling indeed. But I go and find out that there is another application that is being resource hungry, and I go and find that it's from cluster user B, and I go and talk to them and understand more why this is happening. So in larger companies, usually like the infrastructure can be provided as a service, and there are dedicated teams, and so I feel like this overlap where folks understand like, okay, I know where my things are running, but I'm not necessarily going to go beyond the key indicators, but I need to provide that context to the person, because it's not just about, hey, my applications are not doing well. It's like, hey, my applications are not doing well, specifically when they're on this node. This will narrow what the other team can investigate, the investigation space.
Now, assuming someone's using a Kubernetes managed service like, EKS, GKE, or AKS, and some of the infrastructure is abstracted away from them, if they're still in charge of monitoring Kubernetes nodes, for example, what component should they observe and how granular should they go?
So this is actually, I happen to have another diagram for this.
Go for it.
So this is an interesting one. I think most of us think of managed services as something binary. So like either you're managed or you're not managed or self-managed. But there is a spectrum to it, and it's quite important to understand. So in this diagram, like for those that are listening to the podcast, I have the infrastructure, the application layer on top, and I have the infrastructure layer at the bottom, and I've divided it into what is DIY, which is like you manage everything, and then what is more managed, whereas you probably don't manage the control plane, and you might manage the nodes. So from back to the examples that you gave, like you have, if you're using EKS, GKE, you probably the control plane, you're not managing it. You might want to observe it. The challenge here is that sometimes some of the providers make a point on what they allow you to ingest or what data they give you access to or not. There is another model that will fit in here. So GKE has this autopilot mode, which basically means that you don't even have to worry about the infrastructure layer, that nodes will be scaled up and down automatically. It doesn't mean that you can't completely forget, because you need to understand what is going on. And especially if there are issues, same thing, like you need that overlap, that handshake where you provide context to the team that are managing, because at the end of the day, this is being managed by someone or something on the other end. So you need to provide that context if issues arise.
If someone hosts their cluster on bare metal, I imagine they'll also have to look after the rest of the control plane. Does your advice regarding this aspect change in that scenario?
Interesting. Yeah, this gets more interesting. So with bare metal, you need to expand your observability downwards. So when I say downwards, it's like further down the stack, like to include the physical hardware. Because now it's not just about observing nodes, which could be like virtual machines. Now you need to understand the underlying physical infrastructure, because let's say, so everything is on you. If a hard disk fails, you have to go down whatever your servers to go and swap it out. If a CPU is overheating, you need to make sure that you're monitoring the temperature of the room server, or even like the temperature of each server. So this adds another layer of complexity to your observability strategy for sure. One thing that I that I have seen recently pop up in a few conversations is that there is a growing concern about the rising cost of cloud services. But it's the same thing. It's not a binary decision. It's not like, oh, is it cheaper or is it more expensive? It's all about your specific context and needs. So sometimes it can be cheaper to run your own data center, and sometimes a managed model works best. So the key is to balance the cost and benefits based on your particular situation.
Got it. And with all those metrics coming in from the infrastructure, Kubernetes itself, and the running applications, I imagine there can be a fair amount of things to look into. How does somebody know what kind of metrics are available to them?
Yeah, that's a very good question. Yeah, there is a lot of information about, but it can be overwhelming. So I like to frame it in the context of the three pillars of observability. So metrics, logs, and traces. So like we're saying, like metrics tell you what was wrong. So for Kubernetes, you can get metrics from nodes, pods, and the control plane components. So like key metrics like pressure, latency, errors will help you understand the basics. On the logs side, the logs will help us understand what is wrong by providing us with the context. So in Kubernetes, we can gather the logs from the control plane, the pods, or even like basically the pods which are emitting the application logs. And also we can have body logs which can also overlap with security use cases. Finally, with traces, traces represent the interaction between the different components. So they will help us understand where the problems are arising. So to summarize, to start with Kubernetes, I will look at the basics. So node metrics, things like CPU, memory, disk usage, network I/O, pod and workload object metrics, so pod and container resource users, also replica availability in the case of workload objects, and control plane metrics, health and performance of the Kubernetes components. Depending on your use case, you might want to be more interested in one or the other. So if you have a highly available etcd, probably you don't want to be like keeping a close eye on your single etcd. But if you only have one, then probably you might, which is not recommended, but you might want to have a closer look at that. And then on application metrics is relevant depending on the application that you have up and running.
And of the three pillars, it seems that logging is probably the most used and understood. Most companies and engineers might focus only on this, and then the rest could just be considered, let's say, like nice to have. They might sprinkle some Prometheus on top, and that's mostly it. Is that the right way to go, or would you say they're missing out on something?
I have a somewhat, I think, isn't one opinion that is not controversial on this topic. So I'll give mine, controversial or not. I think they do have a valid point. So if you know something is wrong through metrics and you can identify where the problems occur using traces, then logging can be very effective on its own. So because logs provide you with the detailed context needed to diagnose and understand where the root cause can be. However, the challenge comes when you go into more complex systems where correlating all these signals becomes more challenging. So at the end of the day, the real power of observability comes from the ability to being able to correlate these signals. I think this is where, and I mentioned again OpenTelemetry, where projects like OpenTelemetry shine, where we're able to get a unified enrichment of these signals. This will enable to keep that holistic view of your system and not just think about one or the other.
So if all these metrics are stored, these metrics, these traces, these logs, they're all, collected and stored somewhere, what's next? Is at that point, is it safe to say that someone's doing observability right?
Getting the data in appropriately rich is hard, but this is just the beginning. And in fact, if you don't extract value from this data, then it's all for nothing. The next crucial steps are introducing things like alerting and visualization. So with alerting, you ensure that you are immediately aware of critical issues that need your attention. So you need to set up meaningful alerts, but it's not just about setting up an alert on a metric that goes, oh yeah, the threshold has been reached. You need to include more context. So this is where you need to be able to correlate with the other signals. So if you include logs that can help you understand why that threshold was breached or why this is happening, then the alerting will be more effective, especially because you need to think that many times the alert is going to end up in the hands of someone that has probably a very one-side view of your system, and they don't have all the context. So it may be an SRE that is running the applications, but the applications are written by a team that is not on call at the time. So if you are able to provide that person with good context, then it's most likely that you're giving them the best, you're setting them up for success, basically. The other aspect I touched on was visualizations. So I find, like, to me, I'm all about visual. Like, visualizations will help you consume and make sense of vast amount of data. So tools like dashboards allow you to see trends, identify anomalies, and understand the overall health of your system at a glance. Like, we are visual people. I like a book that I read about visual, about God being visual, where basically it talks about 75% of our neurons are visual. So when we are dealing in a world of big data, the more visual that you're able to get your data in, the more visually, the more likely that you're able to spot things that otherwise you wouldn't be able to.
With the idea of, like you said, data, being able to see things, a big part of observability that we hear about a lot is alerting. But in order for engineers not to be overwhelmed by alerts, how do you decide that something is important enough to alert on it? Is there a standard set of alerts that you recommend using, or does it depend on some more specifics?
So let me start with saying this. The most effective alerting strategy is tailored to your specific use case. So standard alerts that include things like CPU usage, memory pressure, disk space running slow, these are fundamental and they can indicate serious issues. But beyond the basics, it's essential to consider alerts that are specific to your environment and what you want to achieve with it. So for instance, CPU thresholds might be different for a container hosting an application that if it went down, then a company loses millions. It's not the same for the same company having another container that is running some background calculations. So the alerts are going to be different. So I wouldn't just go and set up an out-of-the-box CPU alert that at one point will be a 90% and the other one will be a 50%. Without the context on why, then it's very difficult to set something that is effective. So I could say that there are a few tips I can share. So first, based on that, so start with why. Understand your SLAs and SLOs, and because this will guide you into which are the metrics that are critical to monitor and alert. Set the basics. So there are things that we know if they go wrong, we're not going to have a good time. So implement standard alerts for CPU, memory, disk usage, because this will help us catch common issues. Analyze past incidents. This is a key one. Like, I learned this from an SRE, and they told me, like, look, we look at past incidents and we set up alerts that will help them catch them if they were to happen again. And they say that it has been effective. This is like Pareto. Like, sometimes 20% of the causes get like 80% of the results. So if you catch 20% of these, then you're gonna have you're gonna have a better life. Finally, I would say iterate and improve. So regularly review the alerts, especially like you want to remove the ones that are no longer useful. You don't want to go to a point where you have alert fatigue. So you want to add new ones. So yeah, keep it as a regular thing to iterate and improve on the alerts.
There's something else about Kubernetes that Viktor Farsic always complains about, and that's Kubernetes events. What are Kubernetes events, and are they useful for making sense of what's going on in your cluster?
So I like to think of Kubernetes events as structured logs. So these logs capture significant actions and state changes within your cluster. So for instance, an event log might tell us when a pod is scheduled on a node, when it starts running, if it fails, or when it's terminated. So each of these events include a timestamp, the type of event, the reason, and a measure describing the occurrence. So this is why I see them as structured logs.
Viktor also argues that Kubernetes events should be easier for non-professionals to digest. Events should bubble up to the resources that created it. For example, if a pod is deleted, those events will be propagated to the deployment object. When troubleshooting someone's deployments, an engineer could list all the events on the deployments and identify the root cause. This is a bold and interesting idea. Does ingesting Kubernetes events, visualizing and alerting on them help engineers with that? Is Viktor right?
So I think Viktor has a point that, whilst these events are incredibly useful for troubleshooting and understanding state, there is a challenge when it comes to correlating events with all the dependent resources. So yeah, the challenge is that Kubernetes events don't inherently correlate all the dependencies out of the box. They provide raw data, but not the contextual connections between the different components. I find that this lack of correlation can make it difficult to trace the root cause. However, this leads to an important balance that I feel needs to be struck. So where do we set the line between Kubernetes focusing on its primary function, and which is managing containerized application, and providing built-in self-observability features? So one of the main things that people like about Kubernetes is how robust it is as an orchestration tool. And the core function is to manage the deployment, scaling, and operation of these containers. So adding too many built-in observability features could complicate its primary purpose and increase its complexity. But I think there is a need for basic self-observability, which I think is what events are trying to do. But in my opinion, the solution lies in developing decoupled Kubernetes correlation components that would enable this observability without adding complexity to what is already a complex system. So I see here, and this is the third time I quote OpenTelemetry, there is a big opportunity for closer integration of OpenTelemetry with Kubernetes to capture key information like the relationship between Kubernetes resources and understand this without Kubernetes itself having to carry the burden of doing that. So it can remain focused on its core functionalities, and still, we can have OpenTelemetry taking care of that. And so I think Viktor is right about the user needs, but I'm not quite sure that I agree about the implementation being part of Kubernetes itself.
I think if there's one takeaway from this discussion is that there's definitely a lot to learn regarding observability. Do you think this is due to it, perhaps being something that's only recently taken off? And on top of that, where do you see it going in the next 3 to 5 years?
Yeah, so definitely, that's a great point. I think observability has gained significant attention recently, and especially one of the challenges is because we have recently only started to align on the philosophical definitions of what observability truly is. And I think that there's still some way to go. Some people might even challenge the definition that I gave, and even improve it. So yeah, but I think that we are at least aligning, getting to some level of alignment. I know that about where it's going next. I know that it's a bit of a template answer these days, but I truly believe this one. In the next 2 to 3, 5 years, I expect observability to evolve significantly with the integration of generative AI or AI in general. I feel like what I was saying before, like Gen AI can analyze vast amounts of observability data, identify patterns, and it can operationalize a lot of the data that today is on people's brains. And so this will, as a result, like people will become more proactive, and people and teams can focus more on improving their systems than to reacting to issues. And yeah, you're just having like all the information on the tip of their fingertips. So things like you no longer, it could solve even problems like Victor is saying, like you no longer need to become a Kubernetes expert. And in my opinion, like no one should have to become a Kubernetes expert to use Kubernetes. I like to give people an example about, and in fact, I use it as well for how managed is your Kubernetes. Is my why is in transportation. Let's say I need to get from A to B. I can do three takes on this. One is I'm gonna drive a car, but then I'm also required to be the mechanic if something breaks. So that's the full DIY Kubernetes. The managed Kubernetes one is where I drive the car, but if something fails, I have a mechanic on my payroll. And the last one is the one where everything is managed, where I just take an Uber, and that's it. I don't need to worry about cars, or I need to worry about things going wrong. If anything goes wrong, like it's not my problem. Yeah. So this is where I see things.
I like the analogy. One thing, as we wrap up, we noticed on your bio that you do something called visual thinking. For people that are out there that don't know what it is, how do you explain it, and how does it help you do your job?
Good catch, man. So I was knee deep in Kubernetes documentation a few years ago, trying to make sense of the complexity, pod, resource definition, objects. Is it an object? Is it like a live thing? Is it just a definition, etc.? And at one point, I decided to take a break, and I ended up wandering through this local bookstore and thinking like, okay, maybe this change of scenery might help me clear my mind. And my eyes landed on this bright, colorful book with the title Visual Thinking. Actually, I think I have it here. You see? Yeah, it's this one here. So for folks on the podcast, it's from a Dutch agency. It's called, I don't know if the pronunciation is correct, but it's Wheel Me and Brand. It's like wheel as in wheel and me and brand. And basically, the book was filled with drawings, diagrams, and charts, which is exactly the opposite of the dense text that I had been drowning in. And so it caught my attention. And, the visual thinking is the practice of using visuals to process, understand, and communicate information. So as I was saying before, our brains are wired to understand and retain visual information more effectively than words alone. So the idea resonated with me, and maybe, just maybe, this was the key to unlocking the mysteries of Kubernetes. So I started putting it in practice, and I found that it helped me have level conversations with engineers, and I began sketching some of the Kubernetes concepts, and they kind of like came replying and saying, no, this is not this way, this is this other way. And eventually I found like that I was understanding more than just when I was reading the text. So it turned out to be a breakthrough that not only on Kubernetes, but also dealing with even like other complex stuff that I have on my job.
In addition to this, you're an OKR coach. What's that about? Tell us about that.
I'm not a coach. I mean, I don't like to think of myself as a coach. I do have some experience in setting OKRs, so this eventually landed me with some certification. I basically think of OKRs are a fantastic tool for aligning goals and measuring progress. So it's good to have an objective that is paired with a key metric that tells you whether you're going in the right direction or not. And it drives focus on accountability across teams. You need to be careful though, like they can become a hindrance if not kept simple. Like you should just have a few OKRs and iterate on them, because I've seen where they get like overcomplicated and they procreate like rabbits, and all of a sudden you end up like with 100 OKRs, and it can take more away than it adds. So yeah, so I love OKRs, but my initial approach is always tell people like, just keep it simple. Keep it simple.
Now, what's next for you?
I think I gave a little bit of a preview, which is, I think my future is about diving deeper into this intersection of observability and Gen AI. I'm excited. There is a lot of work that can be done of leveraging Gen AI to push the boundaries of what is possible in observability today. Like I was saying, I imagine where Gen AI is not just this pattern of answering questions back and forth, but it's just injected everywhere to help us refine. As it refines itself, it just takes away from us the burden of having to correlate or carry and understand complex systems, and help us improve them.
Lastly, if people want to get in touch with you, what's the best way to do it?
I'd love to hear from people, like especially anyone listening to this podcast. You can find me on LinkedIn. Just look up my name, Miguel Luna. I think, funnily enough, you will always find that there are a few people that have your same share name, and you never kind of like thought that for my name you'll have like 10 or 15 Miguel Lunas, but I think I have a little Kubernetes logo next to my face, so that will help. So feel free to connect. Also, if you're attending KubeCon, definitely drop me a message. I'm probably gonna be there, and I'd love to meet up in person. I'll say hi.
Very good. I can vouch for it that it's definitely worth meeting up and saying hi in person, as we met in the previous KubeCon, and I'll definitely see you in the next one. Miguel, really appreciate your time today, and looking forward to the next steps, hearing more about how Gen AI is intersecting with observability.
Thank you very much, Bart, and thank you for having me.
Pleasure. Take care.
Take care.